Yan, hello guys. Bali, for this video, we will be having our first lecture. For our module 1A, we will be introducing integer programming. Yan. Before that, let's see first kung ano yung basis natin. We have linear programming. Linear programming is a quantitative technique that involves a sequence of steps that lead to an optimum solution to a class of problem. Or we could say we use linear programming for us to get the optimum value, or we could say the best value for us to have a higher profit or a lesser cost considering different kinds of constraints. It is planning by the use of linear relationship of variables involved, and it makes use of certain mathematical techniques to get the best possible solution to a problem involving limited resources. By different kinds of equations down na ating manipulate, we could come up to a value in which na yun yung optimum, or we could say yun yung best allocation for them para ma-meet natin yung target natin. In terms of LP, we could have two kinds of functions or equations or linear equations. We have the objective functions and we have the subjective functions or the constraints. Yeah. Objective functions are algebraic expressions introduced by the word maximize or minimize. Or it's either it is looking for the best possible output from the maximum allocation or looking for the least allocation. But if we have a target, for example, ang target natin is profit, we want to have the highest profit, or we want to get the lowest cost. It could be attainable if you have unlimited resources, or if you have unlimited or unconstrained production, kung wala kang iisipin. But in real life, we have different kinds of constraints or limitations. Meron tayong mga limitations in terms of the production process is subjected to number of employees, kakaunti lang yung employees, yan. Number of machines na pwedeng gamitin, or we could say capacity ng equipment, capacity ng buong planta, yan. Those constraints should be considered in order for us to get the optimum value. Utilizing all those constraints and utilizing all those requirements and resources, we could come up to the best possible, or yung term na optimum value for our objective function. In terms of constraints, we have two kinds of constraints. We have explicit and implicit. Explicits are conditions which are to be expressed in mathematical sentence from the conditions of the problem. Or we could say, siya naman ay makikita talaga natin. Makikita natin, for example, explicit conditions are yung para mabuo si chair, kailangan ng 3 hours. Para mabuo si tables, kailangan ng 4 hours. But ang available lang is 12 hours. We could create an equation from that. That's explicit. Yeah. But implicit, we could also have constraints such as implicit. For example, is sa lahat ng gagawin, we only have 10,000 kilograms of wood, for example. That is an implicit, or hindi na implied siya, or we could not manipulate it. Kasi yung explicit, we could manipulate that. We could add a worker para ma-adjust yung ating explicit constraint. But the implicit constraints, yeah, ay hindi natin siya pwedeng ma-modify. Or normally, kalimitan, ang mga implicit nating constraints are positive. Kaya sabi dyan, the quantity is positive. We have linearity. We should assume na siya ay linear. We could say na siya ay linear. Ibig sabihin ng linear, siya ay gumagamit tayo ng lines. Or we could create equations by not using, but we are not using quadratic equations. Siya ay linear. Divisibility. Yan. Non-integer values of decision variables are acceptable. Kasi kapag siya ay, ibig sabihin, pwede tayo magkaroon ng value na fraction, pwede tayo magkaroon ng value na may decimal places. Yan. Certainty, a value of parameter are known and constant. Hindi tayo pwedeng mag-provide ng LP problem, or hindi tayo pwedeng gumamit ng OR na linear programming kung hindi tayo certain kung gaano katagal talaga siya gawin. Yan. Lahat ng values niyo or coefficients should always be certain. Or, sa Tagalog siya dapat ay strictly na yun talaga, yung time niya, yun talaga yung capacity niya. And we have the non-negativity rule. Kapag lahat ng values natin should always be positive, or we could not consider a value of the x values which is negative. Kasi for example, we need to create 5 chairs and negative 2 tables. It's impossible kasi there is no such thing as a negative 2 table. Diba? Normally kasi, in real life, negative value is not abundant. Kaya, if we are linear, if it is divisibility, if it is If it's divisible, kung siya ay certain at kung siya ay non-negative, we could use linear programming. Kapag hindi yan check lahat, yan tatlo, iba yung gagamitin nating method. Kung hindi siya linear, kung hindi siya divisible, kung hindi siya certain, at kung hindi siya non-negative. We will be considering other kinds of programming methodology. As an example, meron tayong 3 products dyan. Yan, may makikita nyo. Meron tayong 3 different products. We have an objective function which is maximize profit. P is profit of 5x1 plus profit of 8x2 plus profit of 10x3, for example. This is just an example. Having a constraint of labor, gano'ng kadami lang yung kayang i-provide na labor, for example, is 2 hours para matapos si x1, 4 hours para matapos si x2, and 3 hours para matapos si x3. And it should be greater than or equal to 250 hours. Pwedeng yun yung target ni company. The materials is, for example, they need to use at least 100 kilograms, meaning x1 plus 5x2 plus 3x3 should be greater than or equal to 100 kilograms. Huwag malilito doon. Pag ang sinabi guys sa problem is they need to use at least 250 hours, hindi siya less than or equal to. Kasi they need to use at least, ibig sabihin, ito na yung pinakamaliit na value na possible. Meaning, the values of x1, x2, x3 should be greater than or equal to this value. Kasi ito yung pinaka-least na possible. Pag sinabing at most, example, at most 100 kilograms, we will be creating this one as less than or equal to. Lagi yung tatandaan. Kasi nakakalito yun. Yan. If we already have, ang tips ko nga sa students, if you already have found the objective function, nakagawa na tayo ng objective function, nakagawa na tayo ng subjective function or constraints, we are now already 50% finished in computing. Kasi nga, after magawa yan, we could follow certain steps using graphical. Graphical muna tayo. We could represent the unknown problem, tatabulate yung data, maggagawa ng objective function. Yan, nagawa na natin to. Magga-graph, substitute yung coordinates, the vertices. Yan, magpo-formulate your decision by selecting the highest value if maximization and the lowest value of minimization. Kung medyo nalilito pa sa way on solving graphical method, I will be also uploading the link ng aking original video on how to solve it using graphical. Step by step yon, gagawin tong lahat ng 6 steps na to. I will be also adding it on our G-Classroom para ma-refresh kayo. Please watch that video. In terms of IP naman, integer programming, ano yung interrelationship niya kay linear programming? How do we know na si LP ay mother ni IP? Integer linear programming or ILPs are linear programmings or programs with some or all variables restricted to integer or discrete values. Ano ibig sabihin nito? Lahat lang ng values natin is 1, 2, 3, 4, n. Ano ibig sabihin pag siya ay integer? We are not using integer linear programming models do not use or don't accept a result of decimal place and fraction. Kaya siya tinawag na integer. Lahat dapat ng sagot natin should always be whole number. Mapapansin nyo sa mga previous problems nyo sa linear programming, may mga sagot tayo na values ay merong decimal place, may fraction. Yan. Kaya for integer programming, kung natatandaan nyo, it is linear, it is certain, and it is non-negative. Pero hindi siya divisible. Hindi siya divisible. Or hindi siya, ang divisibility assumption natin ay hindi kasama doon. Pag ang ating problem ay hindi nag-accept ng may decimal place, we will be using integer linear programming. Ano po yung importance nito? Paano natin siya magagawa? Kasi for example, you are solving for number of cars. So solve kayo ng number of cars. Gano'ng kadami inyo ipoproduce? For example, ay 5.7. Will you be producing 6 or will you be producing 5? Hindi naman siya talaga totally dapat. In terms of optimization, hindi siya lagi round up or round down. Kasi normally, pag mathematics, we could round up or round down. But in terms of finding the optimum value, pwedeng magbago yan. Pwedeng mas maliit pala yung cost pag ganito, pag ganyan. Kaya we need to get the values of the optimum value which is integer siya. We will not, sa integer linear programming, we will not be accepting any values which is a fraction or which is a decimal place. Ibig sabihin, Lahat ng sagot natin sa LP, pag hinanap yung IP, we need to convert it all into integer program or into integers. Kung si x1, si x2, si x3, dapat lahat yun ay integers or whole number. Ano example? Number of chairs, number of warehouse. Hindi naman tayo pwede magawa ng 0.7 lang na chair para masabing optimum, di ba? In real life scenario, integer programming yung ginagamit natin. But syempre, ang basis natin is si LP. Yan. If some variables are restricted to be integer and some are not, then the problem is a mixed integer problem. Ano ibig sabihin? Pag si x1 is 12 at si x2 is 7.5, siya ay mixed integer. Kasi meron tayong whole number, meron tayong variable, meron tayong whole number, meron tayong may decimal. Kaya siya ay mixed integer problem. Or meron din tayong tinatawag na binary integer programming kapag ang sagot lang is 0 or 1. Yung problems where integer variables are restricted to be 0 or 1 yan, is called 0 or 1 or binary programming. Saan ito ginagamit? Ang assignment problem natin. Di ba ang assignment problem natin is 1 is to 1 is to 1 is to 1. Yan. Kaya we could also solve integer programming. We could also solve your assignment problem using integer programming. I hope nakaka-cope up pa tayo. But before we start, ulitin ko, if you are not yet familiar or nalito kayo or nawala, nakalimutan nyo na, okay lang naman yun kasi nga nagbakasyon, you may opt to open yung isa pang link na sinend ko for you to check kung paano mag-solve using graphical. Kasi on our first topic, sa ngayon, we will just be focusing on the graphical computation. Yung sa ating graphical simple. Graphical linear programming. Say for example, meron tayong problem. Let's try solving this one. GMC Foods Corp operates a regional chain of supermarkets in the Midwest. Recently, its board of directors approved $15.5 million budget to be used for the construction of additional stores and warehouses. Each store will cost $1 million to construct. Palakihin natin siya para hindi natin makalimutan. To construct and contribute an estimated monthly profit of $30,000 ang profit daw. On the other hand, every warehouse, yung store, 1 million daw ang cost, ang profit ay 30,000. Yung warehouse daw, yan, ang kanya daw magiging profit ay 72,000, pero makaka-cost daw siya ng 3 million. Yun yung ating mga values. Nevertheless, the board wants to build at least one additional warehouse. Kailangan daw makagawa ng at least one warehouse, please, at least one additional warehouse, and no more than 5 new stores. Yung mga na-highlight natin, those are the constraints, tsaka yun yung mga values natin for our constraints and our objective functions. Ano yung pwede nating first constraint? E di ito, yung implicit, at least one additional warehouse. Or we could get, paano natin siya isosolve? For example is, warehouse should be at least one additional should be greater than or equal to 1. Diba? The warehouse should be at least 1. Ang sabi, ibig sabihin, at least 1, ibig sabihin, hindi pa pwedeng bumaba sa 1. Kaya ang ating first constraint is, ang ating pwedeng maging constraint dito is, di siya magiging, warehouse should be greater than or equal to 1. And yung no more than 5 new stores. Pag sinabing no more than 5 new stores, ang Tagalog nun ay hindi na pwedeng tumaas sa 5 ang stores. Meaning, stores should be less than or equal to 5. Kasi hindi na pwedeng tumaas sa 5. No more than 5. Ano yun? Ito yun. Should be less than or equal to 5 and our x2 is greater than or equal to 1. Consider natin si x1 is stores, si x2 is warehouse. Diba? Gets yun? Yung at least one additional warehouse, meaning at least one, hindi siya pwedeng lumaki. Hindi siya pwedeng lumiit na 1. Kaya siya ay should be greater than or equal to 1. Then, ang sunod naman is, no more than 5 stores. Ibig sabihin siya ay less than or equal to 5. Ang way of solving, if you want to adapt my way, ang inuuna ko muna lagi is yung mga implicit constraints. Yung mga madadali, yung mga single factor lang, kagaya nito. Then, saka tayo papasok sa mga gastos. As you could see, hindi tayo sure kung siya ba ay maximization or minimization. Yun, may nakalagay dito na ano daw yung maximized total profit. We could already consider na siya ay maximization problem. Pero pag walang nakalagay na pag sinabi lang is please optimize the problem, hindi natin alam kung maximization or minimization. I-check naman natin ngayon. Yung 15.5 million budget, yun yung kanilang budget. Tapos, ang budget, ibig sabihin gagastusin to. Yung gagastusin kay store is 1 million at yung gagastusin kay warehouse ay 3 million. Diba? Tapos yung profit, 72K, yung profit, 30K. Wala tayong target profit. Diba? Wala tayong target profit. Kung wala tayong target, laging tatandaan, pag wala tayong target profit or cost, ibig sabihin, yun na yung ating objective function. Kasi we need to maximize. Yun. Walang nakaset. Kasi itong cost, meron siya nakaset na kailangan ay hindi lalaki ng 15.5 million yung budget. Meaning to say, it's a constraint. Constraint ito. Paano siya naging constraint? Kasi nga si store, ang isang store ay 1 million, tapos yung isang warehouse ay 3 million. We could have a constraint of 1 million, sorry, this is comma. 1 million x1 plus 3 million x2 should be less than or equal to 15,500,000. Ibig sabihin, hindi tayo pwedeng lumaki sa 15,500,000. I hope na-gets nyo yung kung paano nagawa tong budget na to. Yan. Considering na kailangan daw tayo mag-maximize ng profit, ideally we will be just looking for the coefficients of our profits. D yung 30,000 at 72,000. We could get the values of Z, maximize Z, or max Z is equals to 30,000 x1 plus 72,000 x2. And sabi nga nila, we will not be forgetting the non-negativity constraints. x1, x2 should always be greater than or equal to 0. And ngayon, tayo integer programming na it should be integers. Dati kasi ito lang. It should be integers. Yun na yung difference. Dati kasi walang ganyan. After nyan, paano natin siya isosolve? Let's try solving it. Solve na natin kung paano siya. I'll show you something. Yan. Example, yan. I hope you can see it on our screen. Ang first constraint natin is, ito muna unahin natin. Sa pagka-graph din guys, I prefer din to graph first implicit. Kasi siya ay straight lines lang. Wala siyang inclination or wala siyang slope. Let's try first x1 is less than or equal to 5. If we graph that, pag in-graph natin yan, yan siya. This is the line, then ito yung feasible region. Paparto. Ito yung feasible region natin. This is the line, then all the values here is the feasible region. Then, what's next? Ang sunod natin constraints is x2 should always be greater than or equal to 1. Meaning to say, siya ay ito, 1. x2 should be greater than or equal to 1. Pataas naman yung values natin. Diba guys? Then, after that, kasi hindi na natin i-consider itong ibang quadrants kasi we have the negativity constraint, meaning all the values na negative should not be considered. After that, we could now graph the line na isa pang constraint ito. Getting the values of x, setting the value of x1 0, what is x2, getting the values of x2 0, what is x1, using the elimination method, we could get the point of two lines na nag-intersect sa kanilang vertices. We could now get the values of the values or the graph of the third line. This is our constraint 1, constraint 2, and constraint 3. As you could see, ito yung area na feasible. This is the feasible area. Diba? Normally, for us to solve kung alin yung feasible, kung alin yung optimum value, kukuhanin natin ang point na ito. We will be solving for this point. Ito ay 0, 1, 5, 1, hindi natin to alam. Then, ito ay, hindi din natin to alam. We will be solving this. Tapos, we will be looking for the values of z. Ano yung mga values of z pag sinubstitute itong points na ito. And we could say that the optimum value is this one. After solving, yan yung ating optimum value. Yan ay 5 and 3.5. This is 5 and 3.5. Kapag linear programming, tapos na tayo. Diba? Kung titignan nyo, after answering, we could have x1 is 5 new stores and x2 is 3.5 additional warehouses. Tapos, ang monthly profit natin is 402,000 after computing. Substitute nyo si 5 Dito. 30,000 times 5 plus 72,000 times 3.5. Yun yung ating maximum profit na monthly. But the firm must build a complete structure, not a partial structure. Or we could say, hindi naman pwedeng 0.5 lang ng warehouse yung gagawin mo. For now, we will be recommending that we need to modify that 3.5 additional warehouse. Hindi naman basta-basta ka na lang magde-decide na, siya, 3 na lang. Paano kung kailangan yung 0.5? Is it the optimum value? Siya, sige sir, 4 na lang. Paano naman kung hindi siya masyadong gagamitin? Kasi nga, kakalahati lang. Sayang naman yung gastos natin. 3.5 is an impractical answer in real life situations. Kaya we need to analyze kung alin ba yung pwede. Diyan papasok si integer programming. For this video, I will be discussing you I could say the most basic way of solving this one. Pero siya ay matrabaho. In simple problems like this, siya ay madali lang. But in complex problems na ang constraints ay sobrang ng dami, medyo matatagalan tayo. Kasi ang mga values natin is 5, 35, 3.5, ganyan. Pag ang mga values na ay 12, 1,000, 230, for example, malalaki na yung values. Medyo mahirap na mag-isa-isa. After natin makita yan, meron na tayong sagot. Ibig sabihin, pag mali ang graph nyo, pag mali ang inyong pagsasolve ng LP using graphical, hindi nyo ito nakuha, hindi tayo makakapag-proceed sa IP. Kaya nga sabi ko sa inyo, you need to recap kung paano mag-solve using this one, using LP na graphical. After such, yan, pwede na tayong mag-isip. We could consider the rounding approach. Magra-rounding off tayo. Kung mapapansin nyo kasi, we could consider yung 3.5, maalin siya sa 3 or 5. Diba? We could consider 3 or 5. Kasi nga, 3 or 4. Kasi 3.5 siya eh. Pwede ang value ay 3, pwede ang value ay 4. Paano po natin siya ma-analyze? Pag ang x1 is 5 at si x2 is 4, you will be looking at the graph. If x1 is 5 at x2 is 4, nandito yung graph na yon, diba? 5, 4. Ito yung graph na yon, diba? If you will now be analyzing naman 5 and 3, nandito naman siya, diba? If you will be thinking, alin sa kanila yung pipiliin natin? If you will be analyzing si 5, 4, hindi niya nasa-satisfy si alin? He is not satisfying constraint number 3. Hindi siya pasok sa, di ba ito lang ang feasible region natin? Yan. Iisa-isahin niyo siya ngayon. Alin sa kanila ang possible na sagot? Di ba? Kasi, as you could see, hindi natin pwede i-consider si ito. We could not consider this one. Bakit? Kasi nasa labas ng feasible region. Using rounding off method or rounding off approach, ang pipiliin natin is we need to create 5 stores and 3 warehouses. Yun yung isa sa pinaka-basic using the rounding off approach. Pwede natin gamitin yun. Yan. The concern is, pag yan ang ating ginawa, if we consider 5 new stores and 3 additional warehouse, andali, di ba? We could have a monthly profit of $366,000. Comparing dun sa ating una na $400 something, which is ang laki agad difference from converting it and rounding off. Kaya we need to analyze it. Ano ibig sabihin paano siya ma-analyze? Kasi we have other points. Pwedeng 3, 4, di ba? Pwedeng 4, 3, or kung ano man yung whole number. Pwedeng nga itong pwedeng 1, 1, 1, 2, 1, 3, 1, 1, 2, 1, 3, 1, 4, 1, or pwedeng 1, 2, 1, 3, 1, 4, 2, 1, 2, 3, 2, 4, so on and so forth, 3, 1, 3, 2, 3, 3, so on and so forth. Or we could consider all of this one possible. Pwede nating, paano siya yan? Paano mapipili? Kasi if you only use, pag ang pinili mo lang is, if you only use a rounding approach, we could say na it's a quick answer or it could be a quick win, but a large amount of your profit could be an opportunity na sayang naman pag binasta mo na. Kaya we need to analyze all. Lahat ng possible lines or lahat ng possible points which is whole numbers or integers, we need to solve it. Kailangan natin siyang i-solve. So, solve natin kung ano ba yung mga z na mga yan for us to find out which is the optimum value. Yan. In terms of yung graphical approach, yun yung graphical approach na ginagawa natin, yan, we could now enumerate it. Enumerate natin isa-isa. Ano ba yung mga possible points? 01, 02, 03, 04, 05, 11, 12, 13. Sir, paano ko po malalaman kung alin po ang ilalagay kong feasible integer combination? Ay di kung ilan lang yung kasya dito. Kung alin lang yung pasok sa inyong feasible region. Si 15 hindi siya kasama. Diba? Si 44 hindi siya kasama. Kaya you need to analyze kung saan yung feasible region niya lang. Lahat lang nung pasok sa feasible region, iisa-isahin natin, and we will be analyzing which is the best value or alin yung optimum value sa kanila. Isa-isahin natin, substitute si value ng x1 at x2. Saan siya sir isa-substitute? You will be substituting it on our dito. Let's copy this one. Substitute siya lahat dito sa formulang ito. You need to substitute it on this formula para makuha natin kung ano yung mga z. Lahat ng possible, di ba? It's easy kasi nga ipa-plot mo lang, isa-isahin mo lang. But paano na lang pag ang values ay 300 x1, ang pinakadulo sa taas ay 400 x2, di isa-isahin niyo lahat 'yan. In small kinds of graphs, pwede tayong mag enumeration approach. 04, 05, 11, 12. So solve natin lahat ng z value. Siyempre 24, hindi tayo tapos. 31, 32, 33, 34, 41, 42, 44, 51, 52, 53. And then, we will now be looking kung alin ba ang pinakamataas ang profit. On this one, ang pinakamataas ang profit is alin? Ito, 36600. Sorry, ito pala. 378. Tapos, let's look on the original table. Yun. Meaning to say, we could consider now, therefore we conclude that our value of the optimum value of an integer programming model of this problem is x1 is equals to 3, x2 is equals to 4, having a monthly profit of $378,000. Diba? Ano yung una natin napili kanina? Ang napili natin kanina is, diba? Ang napili natin kanina ay, yung nag-eliminate lang tayo. Ang napili lang natin kanina is 5-3. Just considering natin, if magra-round off lang tayo, 5-3 yung pinili natin, 366,000 lang ang ating profit. But, not knowing, yun pa lang after natin maisa-isa, si 3-4 pala, ang pinakamalaki ang profit na magigain. Nasaan si 3-4? 3-4. Yan, ito pala ang largest profit na makukuha tayo compared dito. Kaya, it's not always, pag nag-round off tayo, yun na. Somehow, on some point, nangyayari na, yun ang sagot. Pag nag-round off tayo, round down, yun na agad ang sagot. Sometimes. But, it's not always like that. Kagaya nitong problem na ito. The rounded off value is not always, yun yung optimum value. Saka, hindi din pwedeng ang concept ay kung alin yung mas malapit dito sa optimum value. Mas malapit ito dito. Mas malapit din ito dito. Ito malayo. But we could consider na yun yung highest. Diba? Based sa ating computation, siya yung makakapagbigay ng total monthly profit. Using the enumeration approach, we could now devise a plan of creating 3 stores and creating 4 warehouses, having a potential profit of $378,000. That is the optimum value na natin. Diba? I hope you understand kung paano ginagamit si rounding off approach at bakit ginagamit si enumeration approach. Kasi somehow, pag yung quick, mapabilisan yung pag-solve, pwedeng enumeration. But to get the optimum value, it's either you need to check all possible points. Although enumeration method will provide the optimum solution to any pure integer problem, it is best suited for small-scale situations. Ano yung sabihin ng small-scale situations? Paano pag ang ating values is, for example, ang ating values is, ito ay hundreds. 100, 200, 300, 400, 500. Paano tayo magpa-plot dyan? Siyempre, i-check mo yung 391, 399, 300, 398, 397, 396. Lahat, iisa-isahin mo yung integer. Aabutin tayo dyan ng finals kapag yan ay iyo pang inisa-isa. Or we could say nga, sabi nga dito sa ating slide, we could only use enumeration approach kapag siya ay small scale lang. Kapag maliitan lang yung ating computation. Kapag yon umabot na ng thousands and millions, sir, umabot ba sa ganyan ang mga study? Yes. Kasi in real life situations, ganyan sadya yung mga values natin. Consequently, the decision maker needs some systematic way to solve the large-scale integer problems. Yun ang sabi. Meaning to say, after natin ma-analyze siya using linear programming, we solve it using rounding off method of IP, na-determine natin siya, siya na may doable, pwede naman yun ang ating i-choose, but to get the optimum value, pag maliliit na ganyan, we could consider solving it using enumeration method. For now, for this week, I would like you to review this one ating naging discussion. Kasi, by next week, I will be discussing na, or on the next video, I will be discussing na how to solve it on a different way, na hindi na tayo mag-iisa-isa. Kasi sobrang trabaho na. Kung titignan nyo, yan ay, ilan pa lang, hanggang 5 pa lang yung values. Yung ating graph ay hanggang 5 pa lamang. Paano na for example, siya ay 25 or siya ay 30, siya ay medyo matrabaho nang gawin. Kaya, as introduction, para din hindi mabigla ang lahat, please review your LP graphical kasi nga, hindi nyo mapipili yung mga points kung mali ang inyong feasible region. Yun lang. Please review it. Kasi, pag mali ang feasible region nyo, mali yung napili nyong points, ay di mali ang inyong iisa-isahing points, or aabot sa point na malilito na kayo or hindi natin magagawa yung output. Kaya, for this week, I would like you to review your LP, graphical method, and analyze yung ating video ngayon. Kung hindi enough yung video ito, yung first watch nyo, please watch it again para mas maintindihan. Then, should there be any concerns, please advise me. For this week, my discussion is about the introduction to integer programming using our initial computation approach of rounding off method and enumeration method. These two methods are the easiest, but it is time consuming. On our next topics, we will be thinking of how could we solve it faster and more efficient, or how could we find another mathematical method for us to solve this kind of integer programming problem. I hope you understand something, and God bless, guys. Thank you.